Cancer. Neoplasm characteristics. The more undifferentiated the tumor cells, the more aggressive the tumor. That is, greater anaplesia equals greater malignancy. So the more these tumor cells don't look like the tissue they're supposed to, the more the heart tumor cells don't look like heart cells, the more the breast tumor cells don't look like breast cells, the more aggressive the tumor is going to be. Neoplastic cells are energy dependent. They need the oxygen, they need the nutrients. So they undergo extensive angiogenesis. That means the development of new blood vessels. These blood vessels are what brings all the oxygen and the nutrients to them. But because the tumor is demanding all this oxygen and nutrients, the surrounding tissues are deprived of oxygen and other nutrients, and we end up with ischemia and necrosis of surrounding tissues. Neoplasms also secrete substances that can alter the metabolic processes throughout the body. Okay, benign versus malignant tumors. Benign tumors typically remain localized. They remain in one place. They closely resemble the tissue of origin. So a breast tumor that is benign, the tumor cells look pretty close to breast tissue, breast cells. They have overproliferation, but do not significantly lose differentiation. And they can still cause damage to tissues through compression and obstruction. Malignant tumors, however, are very invasive, they're destructive, they spread to other sites, they don't resemble the tissue of origin. So a malignant breast tumor, the cells don't look like breast cells. They look like something else. They use energy and nutrients and cause ischemia and necrosis to other tissues. So benign tumors can damage other tissues. They do it by compressing them and obstructing blood flow. Malignant tumors can do that as well. They can compress and obstruct things, but they also demand the oxygen and demand the nutrients, and they build new blood vessels to pull the blood and the oxygen and the nutrients away from other cells. Okay, the spread of cancer. How does it spread? It spreads multiple ways. First, it can spread locally and just stay within the tissue of origin. Some of those are benign, some of those are malignant. It can spread by direct extension to adjacent tissues. That means it moves out of the organ it's in, but it moves right next door. Those tumors are malignant. And this process of direct extension also includes seeding inside the peritoneal and pleural cavities. The tumor cells spread along the membranes. And then there's metastasis, where the tumor cells spread to distant tissues via the blood or the lymph systems. Okay, metastasis. We have our primary malignant neoplasm. It starts to undergo angiogenesis, getting lots of extra blood vessels. Now, the picture on this slide, at the top, you don't see the angiogenesis. You have to look at the one on the bottom. But it really is happening in the top one as well. From the angiogenesis, it moves to invasion into the lymphatics and the blood cells. It travels through the blood cells and the lymphatics, but it will get trapped in the capillary beds of the organs, sit there and escape into the new tissue, and there the new tumor is going to grow. Now we have staging and grading. Let's first talk about staging. It's a way of classifying the spread of the disease from the site of origin. And we look at the tumor size, the location, where is it? Do we have lymph nodes involved? Has it spread to the lymph nodes? And has it spread to other parts of the body yet? Those four things are looked at when we stage the disease. Say, how far along are we in the process? Sometimes we stage using the TNM classification system. T meaning tumor size, N meaning lymph node involvement, the N is for node, and M for metastasis. Now, grading is not the same as staging. It refers to the amount of anaplasia within the tumor. Do the tumor cells still look like the tissue of origin, or do they not? A grade 1, the cells are still well differentiated. They are pretty close to the tissue of origin. Whereas a grade 4, they're highly undifferentiated, and they don't resemble the tissue of origin very much.